Section 1A is about basic algebra skills. So let's talk about coefficients, variables, and constants, and how to identify how many terms are written in expressions. So coefficient is the number that's in front of the variable. So if there's nothing there, that's going to be an invisible 1. In number 5 here, it's a 3, and in number 2, it's a 7. We treat these different than constants because this tells us how many of a particular variable. This one would be 4. Identifying the actual variable is a little bit easier. That's just what letters exist. So there's a P here, there's a T there. We could add that P squared is going to be different than P. For each variable to be combined, they have to have the same exponent as well. Finally, identifying the constant. That's the number all by itself, not attached to a letter. There's the 9. Here it's a 1. And if there's not 1, then the constant would be 0, because 12 is the coefficient there. To identify how many terms, you look at each unique letter, and you look at their exponents. Here you can see that there are 4 different terms. This one has 2 different terms. This one has 2 different terms as well, the Q's and the numbers. This would only be one term. 3z plus 4z are both z's. For something like this would be 3 terms. Though x shows up twice, one time it has an exponent of 2 and the other time it doesn't, so they're actually different terms. Back to our review page, the next type of problem we'll look at are those that we simplify by distributing. So on the most basic level, when there's parentheses, that implies multiplication. That means we take the outside term and we multiply it by each term on the inside. So this is like 2 multiplied by 6q. And this is like 2 multiplied by 4. When you're multiplying variables and expressions, you only multiply by the coefficients. So you do 2 times 6, and then you add the letter at the end. So after we have distributed the 2, we have 12q plus 8. And we're done. Let's see one more like that. Distribute the 3. This is 30s plus 6t. Sometimes they have us distribute a negative. Remember that negative is really like a negative 1. So if you're going to multiply, on your calculator you could type in 4.4 times negative 1. And all that it does is switch the sign. So 4.4g plus 10 becomes negative 4.4g minus 10. If we do the same thing in this next problem, distributing the negative, everything flips. This becomes positive 0.5k minus 6. So when you see a negative outside of the parentheses, treat it like a negative 1. The last section of 1a is combining like terms. When we practiced this in Delta Math, they had you do things one step at a time. And that can still work, but we can also do all of the x's at once. When you combine the coefficients, you get negative 3x. Then maybe let's look at all of the y's. 2 minus 1 plus 2 is going to give you plus 3y. Finally, we look at the x squared terms. Remember that whenever there's not a number in front of the letter, that's really a 1. So this would be minus x squared. We have not really solved anything here. We've just simplified as much as possible by combining the coefficients for any like terms. Even if 2 different terms might have an x, you can't combine them unless they have the same exponent. Sometimes when we combine like terms, we also have to distribute. For example, the first thing we do here is we rewrite this. The 5r carries down. This becomes minus 30r minus 12. Then we can combine the r's, and we get negative 25r minus 12 as our final answer. So first distribute, and then combine like terms. It's possible that you'll have to do this twice. For example, if we distribute the first part, we have 6d plus 12. If we distribute the second part, we have 60d plus 10. Notice for each of these, because you're multiplying a negative by a negative, everything turns out positive. And then finally, we can combine like terms. This gives us 66d plus 22. So distribute wherever possible first, and then combine like terms. What about a situation like this? When we combine our x terms, 15x minus 15x, we get 0. So you could write it as 0x plus 7. You can't write it as x plus 7. That would be incorrect. What happens when you have that 0 as your coefficient is the entire thing disappears, and your answer now is just 7. The x's have completely canceled out. Next up, 1b, 1 and 2-step equations. Let's start with the 1-step equations. There's 4 basic operations that we can undo by doing the opposite operation. For example, here x is divided by 4. We can undo that by multiplying by 4. To keep things equal, we do so on both sides. This 4 over 4 becomes 1. You can write that as 1x, but you don't need to. You can simply write it as x. They're the same thing. And what you actually type into your calculator is 8 times 4, and the answer is 32. Notice if you take 32 divided by 4, do you get 8? You do. That means you have the right answer. For this one, we're going to undo the subtraction. You always start on the side with the letter. And since there's a minus 4, we're going to cancel that out by doing a plus 4. We are left with 5.2 because this cancels out. It gives you 0, which means you did something right. And if you were to plug that back in, 5.2 minus 4 does equal 1.2. Even though it says 4 plus x, that's the same thing as x plus 4. So to undo that addition, we're going to do minus 4 on both sides. And this gives me 14 is equal to x. Notice if I plug in 18 is equal to 4 plus 14, that's a true statement. The last of the 4 basic operations is undoing multiplication. And how you do that is you divide by whatever's in front of x, or in front of the letter. And it doesn't give you 0, but it gives you 1, which pretty much goes away. And this is 8 is equal to 1x, or just x. Notice if you plug that back in, 56 is equal to 7 times 8 is a true statement. Other things to watch out for? What if there's a negative in terms of the coefficient? Like you have negative 4t. Well, you can't just divide by 4 anymore. You have to divide both sides by negative 4. And this will give you the answer of negative 1 is equal to t. You have to be careful. If at any point you ever get an answer like 1 is equal to negative t, you're not done, because they asked you to solve for positive t. So if that ever happens, to get rid of the negative, you can divide both sides by negative 1. And that's how you'd end up with this. Sometimes when we're dividing by whatever's in front of the variable, we'll have fractions. So here u would equal to, and when you put this in your calculator, if you press math, enter, enter, it will automatically simplify the fraction for you. The answer that you will get from your calculator is 4/3. That's a nice way to simplify fractions and to make sure that you're reducing them if possible. The final thing you might see in a one-step equation is a fraction in front of the letter. To cancel that out one step at a time, we're going to first multiply by whatever's on the bottom. This cancels out that denominator. So we are left with something like 6n is equal to 15. Then we're going to divide by whatever's in front of. So that was what was originally on top of the fraction. And the last step is to press math, enter, enter on our calculator, which will reduce this fraction for us. Our new answer will be 5/2. That brings us down here to the two-step equations. Let's go back and take a look at how two-step equations worked. Generally speaking, you start on the side with the letter, and we're going to have to get it by itself. So in the end, we'll want to see z is equal to something. So that tells us we're going to try to deal with these two things, the 6 and the 3, or the negative 6 and the 3. It turns out the order we do that matters quite a bit. So we think about the order of operations, parentheses, exponents, multiplication, division, addition, and subtraction, and we work backwards. So if you're going to think about what actually happens to z here, well, you start with z, you multiply it by 3, you subtract 6, and you get an answer. We're going to undo the last step first. We're going to add 6 to both sides. That gives us 3z is equal to 12. Then we're going to undo that multiplication. If we divide both sides by 3, we get z is equal to 4. So whether you learn it through repetition or by following the order of operations in reverse, you have to undo equations in a very specific order. Here's another example. First thing we do is plus 12 to both sides. Negative 7b is equal to negative 49. In my experience, that's the biggest area for mistakes, is making mistakes with negatives. So if you use your calculator, you can avoid a lot of those problems. Notice here the final answer is a positive 7, as the two negatives, when you're dividing, cancel out. The other common type of two-step equation is one that has division, like this, b divided by 2. So if we want to solve that, we're still going to plus 2 first. We have 24 is equal to b over 2. And then we're going to multiply both sides by whatever's on the bottom of the fraction. So we get 48 is equal to b. You are undoing the opposite operation. It's possible there'll be a negative in front of your fraction. So this is how that works. Let's add 27 to both sides, and we have negative b over 5 is equal to a positive 6. Be careful with the negatives. If we want to cancel this out in one step, we can multiply both sides by a negative 5. We could do it in 2, but you're also able to do it in 1. That negative cancels out and the 5 all in one step, and we get negative 30. Two other curveballs we might see are problems with parentheses. For example, x plus 3 on top of this fraction has implied parentheses, and on the left we see the parentheses around x plus 5. Our instinct might be to distribute, but we have options. It turns out, if you were going to follow the order of operations in reverse, you can divide the 3 first. And this tells you that x plus 5 is equal to 4. And then when you subtract 5, you get x is equal to negative 1. Here we can multiply by 4 first, because we do the parentheses part last, and we end up with x plus 3 is equal to 8. When we subtract 3 from both sides, we get x is equal to 5. So for the most part, there's only a couple type of two-step equations, but sometimes the parentheses can throw us off. Last up is the multi-step equations. For the most part, what we are doing on this problem is one or two extra things to turn something into a two-step equation, and then we proceed as before. Here's one example. Here's a problem that has letters on both sides of the equation. You'll see that there's an x here, and this is where the equal sign is, right down the middle. One of the first things we can do is we can cancel out one of those. Doesn't really matter which one, though I'm going to do plus 14x to avoid negative numbers, and this goes away on the left, and I'm left with 1 is equal to 4x plus 13. And notice now I have a traditional two-step equation. I can subtract 13 from both sides. I have negative 12 is equal to 4x. I can divide by 4, and I have negative 3 is equal to x. So when x is on both sides, we're going to cancel out one of them first. Sometimes we call this moving x to one side. Let's look at one more example of this. Let's say that we added 6x to both sides. Notice this is a problem where we have x on the left and x on the right, so I'm going to cancel out one of them. Doesn't really matter which. I'm left with a negative value this time, which is okay. I still follow the basic rules for a two-step equation. I'm going to subtract 10 from both sides. I have negative 5x is equal to 5. When I divide by whatever's in front of x, this time I'm dividing by a negative 5, so it gives me an answer of negative 1. The next type of problem you might see, notice that all of the x's are here on one side only. There's no x's on the right. So if I try to jump straight into something like plus 4x and plus 4x, it's not going to work. For one, notice that I'm adding twice on the left side of the equal sign, and I can't do that. Instead, it's like before, where the first step is to distribute and then combine like terms. So here, this becomes 5x minus 20 minus 4x plus 5 is equal to negative 5. After distributing, everything else just carries down. I combine like terms on the left wherever I can. This gives me x. When I combine the numbers, that gives me minus 15. And then there's only one step left. Add 15 to both sides, and I get x is equal to 10. It's also possible that we might have to distribute on both sides. Let's take a look at this one. There's a couple different things going on. When I distribute the 3, I get negative 12x plus 18. I carry down the negative 3x, and here it's like I'm distributing a negative 1. So this becomes plus 3x minus 3. When I combine like terms on the right side, the plus 3x and the minus 3x actually just go away. So I end up with this, which is a two-step equation. If I subtract 18 from both sides, I have negative 12x is equal to negative 21. If I divide both sides by a negative 12, I can press Math, Enter, Enter on my calculator to reduce the fraction to its lowest form, and I get x is equal to 7/4. One last problem where I only have x on one side. I distribute this negative. I get 5 is equal to 3 plus 6x plus 5. When I combine like terms, I have 6x plus 8, and now I can solve it like a two-step equation. Minus 8 from both sides, I have negative 3 is equal to 6x. When I divide by 6 here, notice what happens. If I press math enter enter, I get negative 1/2 is equal to x. Sometimes when we divide by a bigger number, we just assume we messed up and we switch them. But that's not always the case. Sometimes the answer is just 1/2. All right, last problem, negative 6 plus 9x minus 5 after distributing. So I can put together the negative 6 and the minus 5, and I have 9x minus 11 is equal to, and let's just write it in a similar order like this. Notice I have x's on both sides, so I need to move one of them to the other side, or cancel it out. I end up with x minus 11 is equal to 1. Once I add 12 to both sides, I get x is equal to 13.